Okay, let's try and set up the integral to work out the volume underneath this surface, bounded by this region. So y equals x squared. We are interested in this region. So what that means is you've got a 3D solid looking like this. So this is our region here. That's this region here. And when you shoot straight up, and then here you've got a plane, a slanted plane. So it cuts our solid. Giving you this shape, this volume here. Our job is to work out this volume here. Okay, so to do this, two ways of doing this. We can either do it by using dx then dy, or dy then dx. So in this video I'm going to show you both methods, and they will lead us to the same volume. Okay, so the first step is let's do it by dx and then dy. So if we're working with dx first, then we are moving parallel to the x-axis. So we are moving in this direction. So it's going to be something along the line of x equals something, and then x equals something. So this x must match up with this x. Well, we are moving parallel to the x-axis, so we are moving like this. So we have to start. Well, we start here, and then we move along, and then we stop here. So we move along. So we start here, and then we move along and stop here. So move along, we start here, and then we move along until we get here. So we start at here. What is the x value at that point? Well, it is y. So this would be y, and then where do we stop? We stop here. Where's this here? Well, we want it in terms of x, so we need to rearrange this to make x a subject, meaning it's going to be the square root of y. And then remember, this is nested inside the outer integral here. Well, when it comes to the outer integral, it's always going to be bounded by a constant. Well, it's going to be a constant boundary, meaning well, this is a constant boundary here. Hang on. So you're basically scanning all the way through. Look, you start at y equals 0, and then you're scanning all the way through. So the outer one will always have a constant boundary. So it's going to scan along like this, and then it will stop when you get to the intersection of the two. The intersection of the two is when you set this to be the same as this. So x equals x squared. Take away x on both sides. X squared minus x. Factorize. So it's going to be like this. So the answer is 0. X equals 0 and x equals 1. So it intersects at 0 and it intersects at 1. So that means this must be 1. So y equals 1. Well, anyway, you're scanning from 0 to 1. You're scanning from y equals 0 to y equals 1. So that will then take us to here. So that's the first volume here. We need to do it with the second method, v2. We're going to call it v2, and then right at the end, v1 should equal v2. Anyway, so v2. So this is v2 now. Let's go back here. So let's work out the v2, the volume v2. So it's going to be parallel to the y-axis. So this is the y-axis here. So you're going to move along like this, parallel to the y-axis. So you would start here, and then you move along, and you stop here. You would start here, and then you move along and stop here. So let's set it up. Hang on. So we are moving along in the y direction. So we are moving along like this. Well, if we're moving along in the y direction, then this has to be y equals something and y equals something. Well, we're moving along like this. Well, we start at this place here. We start at this place here. Well, that would be y equals x squared. So we start at y equals x squared, and then we move along and we stop at y equals x. At y equals x. So that's our first setup done. And then the outer integral will always have a constant boundary. So we're moving along like this. We're moving along like this. We're moving along like this. You can see that we're scanning from here to here. So look, we are moving along like this. We are scanning from x equals 0 to, well, we're scanning all the way like this. We're scanning, 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 and then we stop at x equals 1. At x equals 1. So that's our second setup done. Here, that's our second setup done. So now let's evaluate the two. So, hang on. So evaluate the two. So let's evaluate this side. So now integrate this with respect to x. So when you integrate this, it would be 10x. Integrate this, it would be x squared over 2. Integrate this with respect to x. So this thing here is a constant. So it's going to be the constant and then x. From x equals y and x equals root y. So we would then, let's do this bit now. So from here, v2, looking at the inner integral, we need to integrate it with respect to y. So integrate this with respect to y, that would be 10y. This is a constant, so when you integrate it with respect to y, it would be x, the constant, and then y. Integrate this, that will then give you negative x squared. So now let's evaluate this. Let's evaluate this. I need more space, so I'm going to leave this to later on. So this thing, we're going to take care of it later on. Ignore this for the time being. Let's just concentrate on v1. So now I will come back to this later. So let's evaluate this. We are currently here. So now we've got to put this into here. That will then give us this thing here. Put it into here. That will then give us this. Put this into here. That will then give us this. And then you take away, and then you put this into here. That will then be this. And then put this into here. Remember, you're taking away a negative here, so it would be a positive. And then you put this into here. Remember, this is a negative, so you're taking away a negative. That would be a positive. Well, anyway, think about it. It should be this. So now continue. Hang on. If you tidy this whole thing up, it should give you this thing here. And then now integrate this whole thing with respect to y. So this thing here, when you integrate this, it will give you that, because square root of y is to the half, and then when you integrate it, it's y, this thing here, and then 2 over 3. Yeah, when you integrate it, it will give you that. Integrate this, it will give you that. Integrate this, it will give you. Integrate this, it will give you this. And then we've got to put 1 into here. That will then give us this thing here. Put 1 into here. That will then give us this. Put 1 into here. That will then give us this. 1 into here. Give us this. And then you take away. When you put 0 into this, it all disappears, giving you v1 being 1.45. So now let's go back to here. So let's evaluate v2. So we now need to evaluate v2. So evaluating v2. Hang on. So currently v2 is this thing here. So now we need to evaluate it. So put x into here. So that would be 10x. Put x into here. That would be x squared. Put x into here. That would be this. And then you take away. And then you take away. Put this into here. And then you take away. Put this into here. That would then be a positive. Take away a negative. That will give you a positive. And then put this into here. That will then give you this. So now tidy this whole thing up. That will then give you this. And then now integrate it with respect to x. So integrate the whole thing here. That will then give you this. And then you put 1 into here, put 1 into here, put 1 into here, put 0 into here, 0 into here. It will then give you this. And V2 is the same as V1 from earlier. So the two methods leads to the same answer. Okay.